video, we're going to talk about comparing two dependent groups. What is comparing two dependent groups? For example, in this spreadsheet that you can find in the link in this video description, we have the determination of the sodium percentage in a Fritos. The some samples were analyzed using emission and titration. So you have your instrumental method and you have your titration method. The same sample was analyzed using emission spectroscopy and titration. The titration was carried out using silver nitrate. This is a precipitation titration. So you have a classic method that is titration, and you have an instrumental method that is atomic emission spectroscopy. You have to compare these two dependent variables. Why these variables are dependent? Because the same samples was analyzed with the two methods. So we have dependent variables. To compare two dependent variables, you are going to open this spreadsheet in Commander. You are going to data, import data from Microsoft Excel file. Look to my table. I don't have samples names in here. So you'll add this row unchecked. I go to OK, and my data will be imported from Microsoft Excel to it was not imported. Data import from Microsoft Excel file. Okay. Yes. My computer is thinking. When I do this, my data set was imported from Microsoft Excel to my Commander. In the last video of this playlist, I have shown how to open the Commander in your studio. I can click in here to see the data set that I have imported from my Spreadsheet to the Commander. You can see the data set in here. So I have to compare these two data sets. As I show in the first video of this playlist, you might do it using graphs. I can do to in this case, since the variables are dependent, I cannot show the box plots in the same image. For example, I can go to box plots. I don't have group variables, so I can show the box plot for emission. It will be opened in here. I have my box plot for emission, and I am going to show my box plot for graphics, box plots. I'm going to show my box plot for duration. I'm going to apply, and my box plot we're showing here. When you have the two results in separate figures, it's hard to do any kind of comparisons. So my two variables, my variables are dependent. I can compare dependent variables using a Ttest. I go to means comparison, and I use a parity t-test. I use a parity t-test when my variables are dependent. I'm going to parity t-test, and I'm going to compare emission with titration. I'm going to go to options, and I will choose a two-side parity t-test. I'm going to apply, and my results will be shown in my studio mainframe. I have in here the parity t-test. It gives me my t value. We have this 7 degrees of freedom, and it gives to me a p value of 0.00264. This p value is lower than 0.05, so I can say that the results obtained using titration and atomic emission with spectroscopy were different. I can say this. It's very important when you do this kind of test, when you compare two means. You are going to see in the next videos of this playlist, when you have more than two groups, you can compare 3, 4, 5, 6 groups. When you do it, you must know if the variables were dependent or independent. You could do some wrong assumptions when you consider part of the variables as impaired. Just for example, I can consider, I have in the Spreadsheet 2A, I have considered that my variables were independent. It's the same data set, but in here I have done the wrong assumptions that my data set, that my variables were independent. In truth, these variables are dependent, but in here I have shown that they are independent. If I do this, what could happen? So now I am going to do the interpretation of my results, presuming that they are independent, but I know that these variables are dependent. I'm going to my commander. I just close this. I'm going just to close the last windows. I go to data, import data from Microsoft Excel file. I let this row unchecked. Go to yes. And now I will open the Spreadsheet 2A. Remember that all tables that you use in this playlist were provided in a link in video description. I'm going to open. Now my data, it's opened in Commander. I'm going to graphs. Now I can put the two groups in the summary graphic. I'm going to box plot. Okay, and then we're going to apply. Now it is easy to visualize my results. I can see that the emission method provides higher results than the titration method. But looking like that, I could do some misinterpretation of the data set, because these variables were paired. I can do a plot of the means. I'm going to show confidence intervals. I'm going to apply. Okay. Now, when I compare the sodium percentage in Fritos using atomic emission spectroscopy and titration, I will conclude that these two methods provide equivalent results. Why these two methods provide equivalent results? Because I am going to see the standard deviations higher than they are, because I consider that the variables were independent. So when I compare these two groups, uh, and I presume that the variables were independent, I see standard deviations higher than it is in truth. When I consider that the two groups were dependent. So if I do a t-test, presuming that the two variables are independent, I will get a p-value of 0.08. I know that this, and I will get the wrong conclusion. So I have two dependent variables. When I do a t-test for dependent variables, I can see that the two groups were not equivalent. But if I consider that my variables were independent, I will do the wrong presumption that they are equivalent. So it's very important that when you do hypothesis tests, it's very important that you know if your variables are dependent or if your variables were independent. Oh, so you have shown in the first example of this playlist, I have shown the t-test for independent variables. In the second video of this playlist, that is this video, I have shown to you how to do t-test for paired variables. You have to use this kind of t-test when you have paired variables. Anyway, you can also see if your variances were equivalent or not. So I can compare these variances. I'm going to Commander. I am going to Statistics, Variances, choose two variances, F-test. I am going to use the F-test, and I will compare the variances. I'm going to Xstudio, and I see that both methods provided equivalent variances. In this case, I am presuming that the variables were independent. So in the next video, we continue to compare two groups using t-test, but don't forget to look, but we must look if the variables were dependent or independent, and we must check for normality and for equivalent variances. In the next videos of this playlist, I'm going to show some non-parametric tests. If you go to Commander, you go to Statistics, you are going to see non-parametric tests. You could use these non-parametric tests when your data was not normally distributed. But you are going to see this in the next videos of this playlist.